Assalamu alaikum guys, welcome to my channel Electronic Devices Analysis. So guys, in this video we will discuss the common emitter configuration circuit and its formulas. The most commonly used configuration is common emitter configuration, and the most commonly used configuration to process the transistor as an amplifier is common emitter configuration. So guys, this is very informative video to analyze the circuits of common emitter configuration. So guys, let's start with the circuit of common emitter configuration. So guys, let's start with our today's lecture based on common emitter configuration. And our today's topic is the circuit and the formulas based on common emitter configuration. So guys, now we will see the circuit of common emitter configuration. In this circuit, you will see that the emitter branch is common between the input loop and the output loop. This will be the emitter branch, this is emitter branch, and it is common between the input loop and the output loop. How will you determine that it will be the input loop and the output loop? Always the input loop will be where base emitter junction, the base emitter junction of the transistor is present. The loop will called as the input loop of the transistor, and where the collector base junction or collector emitter junction is present, then this junction or this loop is called the output loop of the transistor. So this will be the emitter side and this will be the base side. So it will be the base emitter junction and it will be the input loop of the transistor. So it will be the input loop of the transistor, and the collector base junction or collector emitter junction is present in those loop, then this loop is called output loop of the transistor, because this will be the collector side and this will be the emitter side. So there the junction is present, so it will be the output loop of the transistor. So guys, this is the circuit of common emitter configuration. And here also this junction, the base emitter junction, must be forward biased. Our first step is that the base emitter junction of the transistor must be forward biased. And second point is that in common emitter configuration, the collector emitter junction must be reverse biased. So guys, these are the two steps which we will follow to analyze any circuit of common emitter configuration of the BJT. So guys, the third step is to solve any circuit of the common emitter configuration. You will first have to solve its input loop and later its output loop. From input loops you will get IB from there or IE, and from output loop you will find IC or VC from there, and here also VB, the base voltage will be from there. So guys, that's all. These are some steps which we will follow to solve the circuit of common emitter configuration. So guys, now we will study the formulas based on common emitter configuration. So guys, now we will see the formulas based on common emitter configuration. And in this circuit you will see that the emitter side of the configuration is common between input loop and the output loop, and it is grounded. So there is no resistance present on this branch, so our emitter current IE will be equals to 0. The emitter current will be equals to 0 because it is grounded and it has no resistance is present. So therefore VE will be equals to IE into RE from Ohm's law. From Ohm's law we will take this, and VE will be equals to 0 into RE. So our emitter voltage will be equals to 0. So guys, these are the two specifications which we will give from common emitter configuration. And here From the input loop of the transistor, this will be the input loop of the transistor, this will be the input loop. And here input loop, because this is the emitter branch and this will be the base branch, so it will be the base emitter junction is present, and it will be forward biased because its positive side is connected with the positive terminal of the battery and negative side is connected with the negative terminal of the battery, and it will be forward biased condition. So our base emitter voltage, the drop over there is 0.7 volts because the diode is forward biased over there. This will be the no more than a forward biased diode. And here another formula which we will see from there, that IB, the base current of the transistor, that the base voltage VB will be drop over this junction. So VBB minus 0.7, there is a voltage present and there is also a voltage present. So difference between these voltage over this resistance is called the base current of the common emitter configuration. So VBB minus 0.7 volts over RB, and it will be always equals to VBB minus 0.7 volts, which will be taken as VBE, the base emitter junction voltage over RB. This will be the base current formula. And here from output loop you will find the voltage of VC, the collector voltage from there, and there is a battery present which will be drop over this junction. So this junction will be equals to the collector emitter junction. VCE will be equals to VCC. This battery will be supply voltage to this resistance, so there is a drop over this resistance VCC minus IC into RC. So our VCE will be equals to VCC minus IC into RC, and this will be the junction formula. But what we will have to find VC only, and we will already know that VCE will be equals to VC minus VE, and here VE will be equals to 0, so VCE will be equals to VC. So the formula of VCE and VC will be equal, so VCC minus IC into RC, both have same formula. So guys, these are the all formulas which we will study from common emitter configuration, and there is some specification which we will study, that some specifications are that beta of the transistor, the beta of the transistor is amplification factor of the transistor, because beta is amplification factor and transistor will be used as an amplifier. The transistor is used as an amplifier. The amplifier is what? That if a small signal is applied at the input, the transistor will convert into a large signal. So it will be the amplifier signal which the transistor will be provided to us. So beta will be always equals to IC over IB, and always IC will be equals to beta times IB. This will be the amplification of the transistor, and there is an alpha present which will be equals to IC over IE, and it will be always less than 1. Always the answer of the alpha will be less than 1. The beta of the transistor is always greater than 50 or 60 or greater than 100 or 150. And these are the some values of beta. And the relationship between alpha and the beta, relationship between alpha and beta, that beta will be equals to alpha over 1 minus alpha, and the alpha will be equals to beta over 1 plus beta. These are some relationship which we will derive from beta and alpha. If alpha is given, you will find beta, and if beta is given, you will find alpha from there. So as these are all formulas which we will study, and these are some specification which we will study from common emitter configuration. So guys, that's all for today. Allah Hafiz.